So, today we are continuing with the decision analysis. You have seen on the two previous days we have discussed the structured English, decision tables and decision tree, right. Today let us see a slightly different kind of a thing that is known as payoff matrix. See, a payoff matrix compared to the decision tables is slightly different, right, and it may not be directly applicable to things like in the process specifications. So, payoff matrix is not a tool to be used in process specifications directly. However, it can be used for organizational decision making at a higher level, right. So, it may not be directly relevant to the specifying the processes, but probably it could be a system analysis tool for the top level management. See, what is happening in a payoff matrix? There are two kind of things. One is known as the states of nature. The states of nature are essentially those situations in a decision context on which you do not have a control. Is it all right? Those kind of things on which you do not have a control. For example, whether the states of nature would be the existing situation will continue, or the government policy will be liberal, or some big player would enter the market. It is beyond your control. It is not that you will make a decision on that basis, alright. You are not deciding whether there will be an existing situation, you means your company, or government will have a liberal policy, or some big player will enter market. So, these are states of nature or events that might occur beyond the control of the decision maker. So, what are the these 0.5, 0.3, 0.2, these are like your probabilities. These are like your probabilities, right, that are associated with each of these states of nature that might occur in the future. Now, before the organization or the company, three strategies are available. What are those three strategies? It can do nothing, continue as it is continuing, or it can resort to advertisements, or it can go for restructuring the company. So, we have number of strategies, and suppose you go for do nothing and existing situation continues, then you make a payoff of 2, you get 2. But suppose big player enters market, you get -2. Suppose you want to go for restructuring thinking that existing situation will continue or government policies will be liberal, you may get high payoffs like 7 or 12. But unfortunately, if some big player enters market, you may as well result with a -10 payoff, a very bad scenario, right. So, these are basically expressed in terms of a payoff matrix. You can have different kinds of payoff matrices. This is a simplest kind. Now, this particular diagram is a decision tree. So, you can see every payoff matrix can also be shown in terms of a decision tree. See, this decision tree exactly is the same thing representing the payoff matrix which I have shown before. So, you have a decision point, forget about this 5.1 or the double lines for the time being. We have a decision point, you are deciding whether to go for do nothing, advertisement or restructure. The circular one, see, these I have not told earlier, apart from your squares which are your decision points, we have some circular representations as well. These are actually states of nature, alright. So, these are your states of nature, we can write here as well. So, these states of nature is something which you are not deciding. The states of nature is something that is being decided automatically as if by nature. See, actually nothing is nature here. Big player entering market is also a decision, but this decision is beyond the control of the organization we are talking of. So, the probabilities are written here 0.5, 0.3, 0.2, payoffs are written here 2, 5, minus 2, 4, 8, minus 5, 7, 12, minus 10. So, we have seen that payoff matrix can actually be represented also in terms of a decision tree. In fact, decision tree representation is in a way better. You know why? Because you can actually vary the probabilities. If you think that your decision has something to do, you see, usually the states of nature are independent of your decisions, but sometimes to some extent they matter. To some extent, not to a great extent. Suppose you go for restructure, alright, and maybe many other companies go for restructure, the government may be prompted to go for liberal policies, something of that sort. So, all these things can actually happen. Now, let us see which decision to take and what are the various decision rules that are available to a decision maker to evaluate the payoff matrices. There are essentially 5 types of decision rule. The first one is called maximize expected value, already known to all of us, basically calculation of the expected value, in each case finding out what is the best in the situation. Then minimizing expected regret, for not taking the best possible decision you are having some amount of regret, right. So, you can minimize the expected regret. Then MaxiMax, MaxiMax is an optimistic policy, right. So, you are assuming the best things will continue, or there will be the best scenarios, then take the best decision assuming it will be the best scenario, alright. Maximin on the other hand is you are ultimate pessimist, you are thinking that the worst scenarios will occur, and in the worst scenario what is the best possible situation, that is known as maximin. The Harveys Principle is another thing which is in between MaxiMax and maximin. So, a person need not be a complete pessimist or a complete optimist. If he is in between complete pessimist or complete optimist, then we can either use Harveys Principle, or we can assume he is a rational decision maker and he uses expected value. In fact, something interesting we must tell you here, that you can become an expected value operator only when you have a large business to run. Say for example, if you have 100 trucks, you are doing a transport business and you have 100 trucks with you. Now, you see, if you are in the transport business, you know that since there are trucks and there are a lot of uncertainties in the real world, what may happen? Some truck may undergo accident, something may be seized by police, some may be looted by some people, highway robbers, alright. So, all these kind of things can actually happen. So, you may think, okay, I have 100 trucks, one every year, maybe a few trucks like 4 or 5 trucks will undergo these kind of situation, alright. So, since you are a big operator, you think like this, that okay, 95% of the trucks will make this much profit, 5% of the trucks will make this much loss. So, what is my expected profit? So, you see, a big operator will always think rationally, usually, whereas suppose you are a very small operator, you have just 1 or 2 trucks. See, you have just 1 or 2 trucks and you are in the transport business. What will happen? You can see, even if that 1 or 2 truck actually goes through some calamity like accident or something else, your business is very severely dented, you are in a bad situation. So, this is why individual operators, not big operators, can sometime become either too optimist or too pessimist, right. So, this optimism or pessimism comes in this way. So, there are ways to circumvent this. How to do? Like your insurance. Now, what is insurance? Insurance is something like to make a pessimist operator or an optimist operator and rational operator. So, he should be able to pay some money. So, naturally the question is how much money? So, this is actually comes under the concept of value of information, we will see that also. Then another thing, so therefore what the individual pessimist or optimist person should do, either they can go for things like insurance or they can go for some kind of consortium. That means there are many such small operators together can form a cooperative. So, when you make a profit, you have to pay little bit of profit to the cooperative. When you make a loss, much of the loss is borne by the cooperative. So, basically the cooperative operates in a rational manner, that is expected value operations, fine. So, let us try to see some individual details of these operations. The first one amongst them is the maximize expected value. It is a straightforward thing. I think you all know that since the payoffs were 2, 5 and -2 for 3 states of nature with probabilities of 0.5, 0.3 and 0.2. If you recall, the existing scenario payoff was 2, then liberal government policy payoff was 5 and big player enters market payoff was -2, 0.5, 0.3, 0.2 are the probabilities. When you multiply by the probabilities along with the payoffs, you get what is known as expected value. Similarly, for all the 3 strategies, we compute expected value 2.1, 3.4 and 5.1, and we see that restructure comes out to be the best strategy with the highest payoff, that is 5.1. Now, this is actually shown in terms of in the decision tree. Usually, when you make the decision tree, let us go back to the decision tree. When you make the decision tree, you see we have computed the expected payoffs in each strategies 2.1, 3.4, 5.1, and out of these we have chosen 5.1. So, 5.1 is the decision point, and since we have followed the restructure path, we have the underlined the restructure path. So, this is a decision analysis, decision tree analysis of with expected value, right. So, what we do with each state of nature kind of a thing, we write those values, expected values, and the best one we choose, put it in the decision point. This is a simple decision tree. Suppose a decision tree has got many other branches, many decision points. So, you have to keep on computing at different branches, and finally, suppose there are another decision point with 7, then at the last decision point we put 7, right, because 5.1 is lower than 7. So, this is how this is usually done. Then let us see the next one, minimize expected regret. Our original matrix was 2, 5 minus 2, 4, 8 minus 5, 7, 12 minus 10, right. So, this was our original matrix. Now, what is the regret in each of the states of nature for a particular strategy if you do not take the best possible recourse? You see, let us go back to these payoff, we will come back to this, go back to the payoff matrix once again. See, the best possible payoffs are these. What are these? 7, 12 and -2. See, if you know beforehand that existing situation is going to come, then you should restructure. if you know liberal government policy is going to come, then you should go for restructure with a 12 payoff. But if big players enter market, you should do nothing and get a -2 payoff, right. So, assuming you already know what is going to happen, right, you should be able to follow the best possible strategies. Now, regret comes because when you do not follow the best possible strategies. See, these are the best strategies and these are the payoffs that may occur if you follow the best possible strategies. So, this regret is how much you regret because of that. So, in this case regret is 530, 740 and 038. How these values are obtained? Very simple. 7 minus 4 is 3. So, regret is 3. 7 minus 2 is 5, regret is 5. Minus 10, minus 2 minus of minus 10 is 8, regret is 8. So, this is your regret matrix, fine. Then what you do? You minimize expected regret. Find out again by using the probabilities the expected regret values 4.6, 3.3, 1.6. You can just compute the values and you can see again that restructure comes out to be the best strategy with a payoff of 1.6. Can you see that? Please try to see, do the computations yourself and you will find out that the expected values will be lowest for the restructure. So, restructure has the lowest regret. Is it okay? All of you are convinced that a restructure has the lowest regret. Now, some of you might have already guessed that the regret matrix and the expected value calculations are essentially the same thing. The regret matrix is another side of the picture, is the same thing, looking it from another side. So, because of this it is natural that we shall have the following equations to be true. For the do nothing policy, I have put them together. The expected value is 2.1, expected regret is 4.6, the total is 6.7. Advertisements, expected value 3.4, expected regret 3.3, total is 6.7. Restructure, expected value 5.1, expected regret 1.6 and the total is 6.7. So, you see the total is same in all the cases. As a quick reminder, you just calculate the expected value taking these 7, 12 and minus 2, compute 7 into 0.5 plus 12 into 0.3 plus minus 2 into 0.2. How much do you get? 7 into 0.5, 12 into 0.3 and minus 2 into 0.2. How much you will get? 6.7. Some of you might be thinking that why should we multiply minus 2 with 0.2? If you do not take it, then we get even better payoff. But the point is, you cannot deny the state of nature. Since it is probable, it can happen. Alright, it is not that we wish it away. We cannot wish it away. It is a state of nature, it has to happen. So, you can see that by taking the best values 7, 12 and minus 2, we get a value of 6.7. So, 6.7 is actually nothing but expected value with perfect information. See, if perfect information is available, suppose we are making decision and someone comes up and tells us that this is going to be your strategy, states of nature, that existing scenario is going to be there, no change, alright. If this perfect information was available to us, then we would have got an expected value of 6.7, right. So, for do nothing strategy, the original expected value was 2.1. If I deduct this, we get the expected regret 4.6. This expected regret is also called by another name, that is known as value of information. Why it is called value of information? Because this is the maximum price one can pay for perfect information while following a given strategy. Say you were following the do nothing strategy, alright, and you are getting an expected value of 2.1. Okay. So, you will be getting 2.1, that is your expected value. Now, someone comes up and tells, I will tell you, because of my surveys and calculations and news analysis and so on and so forth, the exact state of nature. For this, you have to pay me 4 in whatever 4 units of payoff, 4 rupees, 4 million rupees or whatever it may be, alright. So, you have to give me a payoff of 4. The question is, will you agree or will you not agree? See, this calculation shows that if you had this perfect information, you can actually get a expected value of 6.7, whereas if you do not have, you would have to be happy with 2.1. So, you would have regretted an amount of 4.6. That is usually called a value of information for this context, right. So, that means you can pay 4, although paying 4 is too high for an information of this type, because whatever however he may say, he may not be exactly correct. I am not going into those complicated mathematics, but you can do. Someone may think that if the person who comes up with an information, he is not perfectly true. If he is giving a perfect information, fine, with probability 1, but suppose his information is also having a certain probability of being true. He says do nothing, that probability that it will be do nothing, he says existing scenario, but really it will be existing scenario has a 90% probability, not 100% probability. Then what will happen? The situation will become a little more complicated, right. I am not going for those kind of complicated calculations, but let me tell you, the value of information is therefore is a very important concept. The basic idea it gives, in an uncertain situation, it calculates the payoff that one should be able to give to an information provider. So, it is nothing but expected value with perfect information minus the present expected value or expected regret, right. That is the concept of value of information. Now, let us look at the MaxiMax strategy. The MaxiMax strategy says, assuming that the best state of nature would occur, choose the best strategy, right. So, let us see what are the things. Suppose you are going for do nothing. Suppose you are going for do nothing. What is the best possible best value? Best value is 5. So, you are an optimist, you are going for do nothing, you think liberal government policy will come. So, I will get a payoff of 5. Similarly, if you are going for advertisements, again you think liberal government policy will come and you will get a payoff of 8. Restructure, again you think liberal government policy will come and you will get 12. So, basically the MaxiMax strategy is modifying these probabilities, putting 1 probability to the best strategy in each case and 0 probability to others, right. So, the MaxiMax operator does not believe these probabilities, he modifies them, makes 1 to the best state of nature and 0 to others, fine. So, that is what happens. Do nothing 5, advertisement 8, restructure 12. Now, incidentally all are same, but it may not be same, in some situations they may be different, right. So best payoff is 12, best strategy restructure. So he goes for restructure, right. This is known as the MaxiMax strategy or the optimistic strategy, right. On the other side of the coin, we have the pessimist operator. The pessimist operator is going for the maximin strategy. So he assumes that the worst state of nature would occur. So he assigns a probability of 1 to the worst state of nature, and he chooses the best strategy out of those worst scenarios. Let us go back to the decision tree. So incidentally all are like similar. In this case, if he goes for do nothing, he assumes the big player would enter the market and he would get -2. If he is going for advertisements, again he thinks big player would enter the market, he gets -5. If he goes for restructure, he assumes big player is coming and therefore he gets -10. So this is put here, do nothing -2, big player enters market, advertisements -5, big players enter market, restructure -10, big player enters market. So in each case he chooses the worst state of nature, and after putting the payoff, best out of these three is do nothing. So the maximin operator will go for do nothing with a payoff of -2, right. So we have seen the maximax operator and the maximin operator both. The Harveys principle is a compromise between the two. What he says, it says that a decision maker's view may fall somewhere between extreme optimism maximax and extreme pessimism maximin, right. Harveys principles provides a compromise to depict different levels of optimism. Thus the decision using Harveys principle depicted with a degree of optimism alpha would be alpha into maximax decision plus 1 by alpha into maximin decision, alright. So it is a weighted average. Suppose if you think that degree of optimism is let us say 40%. So if you think it is 40%, then you multiply 0.4 with maximax decision and 0.6 with maximin decision. Is it okay? So this is how you can calculate in case of Harveys principle. So it is a compromise. Let us see how we compute. I want to just see little bit more. Alpha into maximax decision plus 1 by alpha into maximin decision. That is the decision using the Harveys principle. Is it okay? Right. So let us see this Harveys principle, a calculation with degree of optimism alpha equal to 0.6. So do nothing, maximax is 5, maximin is -2. This we have already seen. Harveys 5 into 0.6 plus -2 into 0.4 comes out to be 2.2. With advertisements, maximax 8, maximin -5. Harveys 8 into 0.6 plus -5 into 0.4 equal to 2.8, right. Restructure, maximax 12, maximin -10, Harveys 12 into 0.6 plus -10 into 0.4 equal to 3.2. So we see again best payoff 3.2, best strategy restructure. Now calculate once again with degree of optimism alpha equal to 0.5. Calculate once again with alpha equal to 0.5. If alpha equal to 0.5, then it is easy, it is a simple average, is it not? So for do nothing, it is 5 minus 2 by 2, that is 1.5. Can you see that? 5 into 0.5 plus -2 into 0.5 basically equal to 5 minus 2 by 2, alright, which comes out to be 1.5. For how much is this for advertisements? 8 minus 5 by 2, 1.5, and restructure 12 minus 10 by 2, 1. So, what is our strategy then? Our strategy will be either do nothing or advertisements. So, you can see that with 0.6 restructure, with 0.5 the strategy changes. So, as you increase the degree of optimism, probably you move towards restructure. As you decrease the degree of optimism, you move towards do nothing. So, one end is do nothing, another end is restructure. You move from do nothing to restructure depending on your degree of optimism. Fine. So, basically what we have covered today in these payoff matrices is there are various kinds of decision rules or strategies, and basically there are two operators, expected value and Harveys, which actually depicts the reality more correctly rather than the strategy like Maximin or Maximax, which are extreme optimism or extreme pessimism. Nobody is exactly like that. No, anybody has some degree of optimism. One very special case is perfect rationality, right? He assumes all states of nature with the probability which is actually available. From there we can compute the expected regret, which is a measure of value of information, right. Now let us look at a slightly different kind of a thing, that is certain biases that are actually present in human decision making. Basically, let me reiterate that whenever you are developing information systems, most of the time you cannot automate fully. It is not possible that you make a complete automation. Since you are not going to make a complete automation, what will happen that you have to deal with people. See, even if you do complete automation, the people is inevitable, you cannot move away or move out the person. The persons are different, right. So, suppose in the old days, let me give you an example how different kind of people have got different kind of bias. At that time, instead of automated online processing, there was what is known as batch processing. What is batch processing? It is not processed immediately. Whenever a batch is created, then the batch is to be processed based on the human intervention. Now, when I was transferred to the EDP department, that time it was called data processing department, I was made in charge of printing job card, root cards and this kind of thing, right. So, on the very first day, Mr. X, let us call him, Mr. X met me. Mr. X is going to be my client. He would give me the job card requests and those sort of things. Fine, everything went right, and I was basically, he gave me some request and I was about to prepare the job card and root card. Suddenly he came to meet me one afternoon. He says, when do you want your jackfruits? What jackfruits? I got totally overwhelmed. What is this jackfruits he is talking of? Then I could find out the person who was there before me, who has been transferred elsewhere, and he was printing those job card, root card, he used to pile them up, and until unless this man whose house was having lot of jackfruits brings some jackfruits, he would not process them. So, this is why this man is also offering me jackfruits. So, look at this, basic idea is that there are lot of human things that come into play. Right. Obviously, I am not talking about jackfruits here in these biases, but it is whenever you are dealing with human, you have to think about all these possibilities. If you are making an information system, you should try to see that the human intervention should be there, but how to control it in the best possible manner. Alright. So, that is what is required. So, there could be biases that can come due to data acquisition, processing of information, related to output, related to feedback. Let us say the first one, that is the data acquisition biases. This is data acquisition means when you are collecting data, what are the different biases that are coming into picture. The first one called the availability bias. This is the frequency of well publicized events are usually overestimated, right. Suppose some data is available, you tend to believe that that is the data, that is the thing, right. Suppose some people say that you are taking that course is too heavy, but really speaking that particular data that is available to you, which your senior might have told, may not be correct at all. The course may not be too heavy, alright, but since somebody is saying and it is an information which is available to you, you tend to believe that. So, we give lot of weightage to newspaper reports, to something that has been written, alright, that instead of putting big weightage on that. Then selective perception, own experience bias, what one expected to see, people usually downplay or disregard conflicting evidence. So, I have already told you that whenever you are going for let us say existing system, what is the existing system, and you are going for system analysis, most of the time you see what you expect to see, right. Whatever you have read in the book as inventory systems, even if it is there or not there, you assume it is there, alright. So, even if you get something else, you tend to downplay or disregard. Frequency bias is very common. Absolute number of successes are more important than relative number of successes, alright. The success stories are so much publicized that for every success, there are hundreds and thousands of failures. That is often forgotten, is it not? Every year or every year, every month, thousands of young boys or girls also, they make a trip to Mumbai to become actor or actresses. How many succeed? We hear only one Mithun Chakraborty kind of person who actually succeed out of all these. In fact, while I used to study in my school, one of our classmates have gone, and we later on heard he is become the servant of Hema Malini. So, that was the success that he has achieved. So, point is, these stories are not told, these stories nobody tells. We only hear that Mithun Chakraborty has become big, alright. So, we tend to overemphasize. You see, we all buy lottery tickets. Why? Whether you buy lottery tickets or not, whenever there is some kind of a lottery, you think, okay, I have a chance. But what is your chance? But you say, okay, no, that man has got. Since that man has got, you can also get. But how many have not got? You don't want to see. So, this is called frequency bias. Then, concrete information bias. People tend to rely more on concrete information rather than on statistical information. See, actually what happens, this is the bias that people usually tend to use while influencing people. For example, you are making an MIS report. See, these are relevant in this way. Every MIS report has a purpose. What is the purpose? Suppose you are going to introduce a new kind of product in the market, whatever it may be, suppose it is a new kind of paint. So, when you want to introduce that new kind of paint, you want to put the positive points about the new kind of paint. You can say this paint will be qualitatively better than other paint. You see, this is not very concrete. You say qualitatively better, you say it will be more pleasing to the eye, or you say it is using much better chemicals. You see, what is pleasing to the eye, what using better chemicals, these are very difficult to concretize. Whether it is true or not, suppose you say if you go for this new paint, you will save 1000 rupees every year. See, this becomes a concrete information. People understands what is rupees 1000, how much they can do with rupees 1000. So, moment they give a concrete information, people tend to bias towards that, alright. So, this is why, since the money is one of the most concrete things, anything that is expressed in terms of money, people tend to depend more on that, alright. Not only concrete information, it has been seen the decision makers, suppose he has less information rather than more information, but this less information is concrete, that is there are not much of conflict or different opinions about that information, they tend to rely more on that, fine. Then illusory correlation, this basically says that people usually choose inappropriate variables for predictions. Basically it is like correlating one to the other, alright. One event has happened and the other event has also happened, people tend to think that these two are related, alright. Many a time it may not be so, right, you assume a correlation which really is not there. Then obviously there are different kinds of data presentation biases, because when you are collecting data, these data you are collecting from some reports, some kind of manuals, so there might be lot of data presentation bias. Some other day we will discuss data presentation bias in detail. There are various kinds of things that may possible: order effects, mode of presentation, mixture of qualitative and quantitative, logical data display. That means how you are presenting your data is very important. Suppose you show something graphically, the scale that you are choosing, it can make a lot of difference. Then let us see some information processing bias. While processing bias, you see these biases basically that of people, and you cannot rule out information processing by people as well. Inconsistency, people are sometimes inconsistent in their processing of information. So, sometimes the same thing you are processing, you give, suppose you have to give a subjective weightage, you may give 7 out of 10, in another time you may put 8. So, you may not be completely consistent. In fact, it has been seen, that is called bootstrapping. Bootstrapping, the very idea of bootstrapping is, suppose people are making decisions, if you can by some means find the decision rule that the people are following and replace the person with that decision rule in an unchanging situation, that means in a static decision making situation, you will find at least a 5 to 7% improvement, 5 to 7% improvement, more so in game kind of situation. Suppose some people are playing a game, a computer based game, and they are following some strategy. If you could find out what strategy they are using and replace the person and use this strategy in an automated manner to make those decisions, you will see a 5 to 7% improvement in behavior. That is actually the measure of inconsistency of people's decision making, and this concept is called bootstrapping. Conservation, decision makers are often conservative in the sense they do not want to take risk, had to have fixed ideas. Then decision makers are unable to visualize exponential growth or decay, in which case the growth or decay may be nonlinear and dramatic. See, exponential decay or growth has a particular thing, you all know it, that is called constant doubling time. In the decay process, it has got a constant half life. So, what happens? Suppose something is growing, initially it may have filled up only 1/16th of the whole thing, right. Then as one period goes, it become 1/8, 2 period 1/4, 3 period half, 4 periods full. So, it is like this, in 4 periods from 1/16th it becomes like this. A common question where people do not understand the rate of growth of population in our country. You see, today our population is around 100 crores. What will be the population 100 years from now? Give the simple answer. Today our population is 100 crores. What will be the population of our country 100 years from now, if this rate continues? No, you say in terms of crores. 160. You see, when somebody says 160 crores. Any other opinion? Any other? 200? Any other? You see, you people are supposed to be the most learned. They don't take it lightly. You people are supposed to be most learned and most intelligent group of people, but even then you are so much grossly wrong. Then what about the common man? The fact is, today the growth of population, particularly India, the doubling time is less than 50 years. It will be somewhere around 40 to 45 years. Alright, this is the fact. So, these basically means in another 40 years our population will be 200 crores, in another 80 years it will be 400 crores, and most likely in 100 years time the population will become 500 crores, which does not mean in 200 years it will be 1000 crores. It basically means in 200 years the population will be roughly 2500 crores. It is that, let us accept the fact, it is exactly that. So, please think about it. See, the doubling time, this is, you see, it is a very good example of this nonlinear extrapolation is not understood by people, just they do not understand. Right. Now, there are other kinds of information processing biases. For example, heuristics to reduce mental efforts. People use all kinds of rules of thumb, anchoring and adjustments, representativeness, law of small numbers, and justifiability. See, anchoring and adjustment particularly, let us explain little bit. Whenever we make a decision, we usually take an anchor and we adjust values around that anchor. Suppose we may take an anchor of 500, how much should be the production in a production shop? So, instead of doing complicated calculations, mentally we make an anchor value 500, alright, a target value. Then we adjust around these 500 value, right, 500 plus minus 30. Usually this is how human decision making takes place. Then there are different biases due to decision environment, such as complexity, emotional stress, social pressure. These are very important factors based on which the decision environment can be highly modified, in which the person is making decisions. Then bias from information sources. The information source may not be consistent or data presentation may not be available. Before we move to the next thing, just one more thing, that is the law of small numbers. See, law of small numbers, usually what happens whenever we are estimating something like your let us say standard deviation or variance, usually what happens, if you take a small sample, on the basis of small sample we get a value definitely, but the variance can become very high, right. So, suppose you have taken a sample of 2 and 1 comes out to be success, you tend to think 50% would be successful, but who knows, your variance may be as high as 40%. So, that means your result could be anywhere between 10 to 90%. So, what can you depend upon that, right. So, this is where people are usually making mistakes. 2 more slides. The output related biases. There are things like response mode, question format, scale effect, wishful thinking, illusion of control. These are some of the things that are usually related to outputs, right. Wishful thinking, that you are thinking that things will turn out to be better. So, your output may be made according to that. See, the output what it is showing is not the real value, it is the wishful thinking of somebody else, alright. Sometimes the output is shown in a manner as if the control is present, right. So, these are some of the things. Then depending on the different formats and scales or the way responses are made, the output can actually show different behavior. We will discuss this little bit while we discuss user interfaces. So, let us see our last slide, the different kind of feedback biases. The first one, outcome irrelevant learning structure. See, many a time when we are selecting a person, we think that we have selected the best person, but what about the rejected candidates? We do not keep further data about them. Who knows, we might have missed a candidate who could have been even better. Then gambler's fallacy, misperception of chance fluctuations, right. Suppose you have tossed a coin, 3 times it has come head. What is the probability that it will be head 4th time? You may think 3 times it is head, 4th time it may not, should not be head, it must be tail, but it is not so. The 4th coin is another coin. So, the 4th coin has again 50% chance of being head and 50% chance of being tail, alright. Just because 3 times it has come out heads, 4th time need not be tail. Then we usually attribute success to hard work and failure to hard luck, alright. Because of this we do not learn from our success or failure. Then logical fallacy in recall. When people are involved, the eyewitness testimony may be wrong, right. Many a time we may think that we are getting an eyewitness testimony, but people may not recall it exactly. The last one, hindsight bias. Decision makers are not surprised about past good results, they can always find ways to explain them. So, it is like you become more knowledgeable after the thing has happened, right. When you think about your past, you think, why did I make those mistakes, but who knows, in future you may be making the same mistakes, alright. So, that is called hindsight bias. Actually, it is the nature of human being, until unless you can explain your existence, you cannot survive, as simple as that. Even a dacoit or a criminal or a culprit, he has his own logic of explaining his situation. That means every person has his own rationality. So, if you have some sort of behavior in the past which you do not like to be associated with yourself, you have to find a reason for this. You cannot keep it unexplained. So, you have some explanations, you have found an explanation, that means you think it is under control, but the fact is it may not be under control, right. We will stop here today, and our next class we shall discuss the structured charts, basically system design, right. Thank you very much.